guys, welcome back to my YouTube channel. Today I am going to solve day 29 problem of this month on LeetCode. Before starting, if you guys haven't subscribed my YouTube channel yet, then please go ahead and subscribe it. Now without any delay, let's get started with today's problem. So today I am going to solve problem number 2192, all ancestors of a node in a directed acyclic graph. Okay. So in this problem you are given a positive integer n representing the number of nodes of a directed acyclic graph, and the nodes are numbered from 0 to n-1 inclusive. Okay, so let's say if there are total n nodes, 8 nodes, then you are numbering the nodes from 0 to 7. Okay, so you are also given a 2D integer array edges where edges of I from 2 denotes that there is a unidirectional edge from 2 to in the graph. Okay, and we have to return a list answer where answer of I is the list of ancestors of the ith node sorted in ascending order. Okay, so note this point, ascending order. Okay, sorted in ascending order. A node U is an ancestor of another node V if U can reach V via a set of edges. Okay, so see this example one. Okay, so here at this particular 3, okay, I can reach from node 0 and I can reach from node 1. Okay, so that is why I am writing here 0 1. Okay, for this node 4 I can reach from 0th node, I can reach from 2 node, right? So that is why I am writing 0 2. Okay, and for this 5 node, okay, so this is nothing but 0 1 2 3 4 5 6 7. Okay, this is for 5th node. Okay, so for 5 you can see that I'm reaching from this 3 node. I can start from 0, then again I can reach to the 5 node, and from 1 if I start, then again I reach to this 5. Okay, so that is why I'm writing 0 1 3. Okay, and this is for 6. So for 6 I can reach from 3, I can reach from 4, I can reach from 0 0 3 6, I can start from 1 3 6. Okay, so 1 also I can start from 2 as well, 2 4 6. Okay, so that is why I am writing here 0 1 2 3 4. Okay, and this is for 7. For 7 I can reach from 3, I can reach from 2, and I can also start from 0, right? I can also start from 1 1 3 7. Okay, so that is why for 7 I am writing 0 1 2 3. Okay, so n is equal to 8. That means simply means 0 to 7 we have to find, right, one by one. And this edge list array is just representing that from 0 to 3 there is one path. Okay, from 0 to 3, and it's not like 3 to 0, only from 0 to 3 there is one path. Okay, from 0 to 4 there is one path, from 1 to 3 there is one path, from 2 to 4 there is one path, right? Okay, so here see, nodes 0 1 and 2 do not have any ancestors, so that is why we are just writing null here. Okay, node 3 has 2 ancestors 0 and 1, node 4 has 2 ancestors 0 and 2, node 5 has 3 ancestors 0 1 and 3, node 6 has 5 ancestors 0 1 2 3 4, right? And node 7 has 4 ancestors 0 1 2 3. Okay, so I hope that this is clear, right? So how we are going to solve this problem? Okay, so first see here, from 0 I am going to 4 and 3, right? From 1 I am going to just this 3, right? This is what I am writing. From 2 I am going to 4 and 7. From 3, see this arrow, I am going to 5 and 6 and 7. From 4 I am going to 6, right? So I am writing like this. From 5 I am not going anywhere, from 6 I am not going anywhere, from 7 I am not going anywhere. Okay, and here this is from to 2, this is 2 from. Okay, so see here, 0 there is no ancestor for 0, so I am writing nothing here. No ancestor for 1, writing nothing here. No ancestor for 2, I am writing nothing here. For 3 I can come from 0 and 1. Okay, just see this arrow, 0 and 1. Okay, for 4 I can come from 0 and I can come from 2. Okay, 4 5 3. Okay, so only this arrow now. Okay, direct path, I am writing direct path, 2 from, So for 5 I can go from 3. 4 6 I can start from this 4, or I can start from this 3. Okay, so only two direct paths, right? For 7 direct paths are this 3 and this 2. Okay, so from here one thing is clear: for 0 there is no ancestor, for 1 there is no ancestor, for 2 is not ancestor, so I am just returning null here. Okay, so see, I am just writing null. For 3 0 and 1. Okay, for 3 0 and 1. Okay, writing 0 and 1 here. For 4 0 and 2. So for 4, see, 0 and 2 is my output, see here. And for 5, see now carefully, for 5 3, and then after that I am checking the neighbors of this 3 as well. Okay, in this map, so I have to visit this 3, then I have to visit all the childs for this 3. Okay, here, so 0 1. Okay, so for 5 my output is 0 1 3. Okay, I have to sort the list as well, 0 1 and 3. For 6 3. Okay, mark it as visited. Then for 3 check what are the nodes, 0 and 1. Okay, write 0 and 1 here, 0 1. Okay, then we have marked this as visited as well. Okay, 4 6 0 and 1. Now visit 4, mark this 4 as visited, and see the childs. 0 we have already visited, right? So I don't need to do anything, write anything here. Okay, and for 2 we haven't visited yet, so here I have to write 2 here. So 0 1 2 3 4. Okay, 0 1 2 3 4, 0 1 2 3 4. Okay, same way for 7, first we go to this 3. Okay, mark it as visited. So I am using this pen. Okay, so I marked it visited 3, and then mark the neighbors of 3. So 0 and 1. So mark both of them visited. Okay, so here write 0 and 1. Okay, and then go to this 2, mark this 2 as visited, and see the neighbors of 2. No neighbors. Okay, so that's it. So 0 1 2 3 we have to sort the list. 0 1 2 3 is my output, right? So see, it's very simple, right? So we have to just do the following things. Now let's move to the coding part. So first let's create one map. So in map you see I'm storing these as keys, and here in the from I'm storing one list of integers, right? This is nothing but list of integers here. Okay, integer and list of integers. Okay, so that is why I am writing here integer and list of integer graph. Okay, and we have to return our result as well in the end. So let's create a list of integers for a result. Okay, copy this list of integer, new. Okay, now let's create one boolean array. Okay, so we have to mark the nodes which we have already visited, right? So let's create one boolean array. See, now inside this function, first let's write graph is equal to new hash map, right? Okay, now let's iterate over all the nodes. Okay, so if there are n nodes 8, then we have numbering from 0 to 7, right? So here I am writing for int I is equal to 0, I is less than n, I plus plus, and here graph dot put I new array list. Okay, so let's create one empty array list for all the keys. Okay, new array list. Then after that let's iterate over all the edges one by one. Okay, okay, int from is nothing but from edge 0, right? And 2 is nothing but edge of 1. So we are iterating over all the edges one by one now. So see here, this 0 is my from and this 3 is my 2. Okay, so from is edge of 0 and 2 is edge of 1, right? This is done. Now we have to fill our map, right? So here write graph dot get to, okay, and add the values. Okay, so from, this is what we are adding, right? To from, okay, into I am adding from, right? Into I am adding from. So this is done. Now after that, let's iterate over all the nodes one by one. Int I is equal to 0, I is less than n, I plus plus. First here let's define this, initialize this boolean array, new boolean. Okay, so by default it is false, right? By default our scene array is false right now. Okay, inside this let's create one list. Okay, so now we are going to create the list. Okay, here like this 0 1 3 0 1 2 3 4. Okay, we have to create that list of integer, and let's name it as list li, and here just call one method dfsi. Okay, so here let's pass my I value. I is nothing but my node, and after that just pass one empty array list. Okay, new array list. Okay, so I am expecting this dfs method to return me a list. Okay, like something like that, 0 1 2 3 4. Okay, some list. So now after getting that list, I have to sort the list in ascending order, right? Collections dot sort this list. Okay, and in the end just add that result, that list into my result. Okay, this result, so result dot add this particular current list. Okay, and in the end we have to just return the result. Okay, so now let's define this method dfs. Public list of integer dfs int node, and here create our list, right? List of integer. Okay, this is done. Now inside that just mark that particular node as visited first. Okay, so we have to mark that node as visited, so just mark it as true, and then iterate over all the neighbors of that particular node. Okay, here write graph dot get that particular node. Okay, after getting that node, just check if whether we have visited that neighbor or not. If not visited that neighbor, okay, if we haven't visited that neighbor, then add that neighbor into my current list, right? This dot add neighbor, and then after adding that neighbor we have to again call the method dfs for that particular node. Okay, for that particular neighbor. So this time my node will become neighbor, and here just pass my list. Okay, that's it, and in the end return the list. Okay, so now let's run the code. All the test cases has been accepted. Now let's submit it. So see, our solution is accepted, right? And we have completed streak for 150 days, right? So see here, I am moving over all the nodes one by one. Okay, so here my time complexity, let's say of n. Here I am iterating over all the edges one by one. So here of e, okay, of n plus of e here, and here also I am iterating over all the nodes one by one. So of n, and inside that I am iterating over my list. Okay, so inside this list I am iterating over all the neighbors, right? So I can say that of n plus E for this one, okay, in the worst case scenario. Then I am sorting my list as well, okay. So for the sorting process n log n, but for n number of nodes I am doing this sorting, so it is going to be of n square log n, okay. So overall time complexity I can say that it is going to be of n square log n, okay. So I hope that you guys are able to understand today's problem. If you guys still have any doubts, then please feel free to ask in comment section. Till then, keep coding and keep practicing. Meet you guys in the next video. Thank you. Bye bye.